To give a quick overview of the logistics of the Webex and how to participate.
Absolutely. Good morning, everyone. Thank you for joining us. We will record the session today, so your participation is your consent to be recorded. Should you choose not to be recorded, you can either ask your questions in the chat mode or send them to us via email. We'll get those answered for you as quickly as we can. You'll see your controls along the bottom of your screen. You can unmute yourself if you would like to ask questions verbally. You'll see on the far right-hand side, you should see a chat window. You can open that up, ask your questions in there. Go ahead and introduce yourself to everyone. Tell us your name, where you're from, and we'll be happy to engage with you folks there. There are also emojis at the bottom of your screen where you can raise your hand, you can give a thumbs up, celebrate all those great things to help you engage with the presentations today. If you have any questions, be sure to let us know. Other than that, I'm going to turn this back over to Mark.
Am I? Yeah, thanks.
Yep, you're unmuted now.
No. Apologize for that. I think a big seagull just flew into a window and it really riled my dog. Anyway, good morning, everyone. I'm going to share my screen here and put it in presentation mode. There we go. Is that in the right mode, Robin? Yeah, great. Okay. Mark McGranigan, as I said, I'm with EPRI in our EPRI Europe Dublin office, and we're very excited about this week of workshop sessions to look at collaboration opportunities around innovation that's going to be required for the Fit for 55 agenda. This is we have a plenary session to kind of have a high level discussion of what some of those challenges are and looking at the opportunities for collaboration that maybe can set the stage for the more detailed discussions that we will have in other sessions during the week. It's a great panel for the discussion this morning with Roberto Zangrandi representing Ensoy. Ellen Diskin will represent Euroelectric and also give a perspective from work going on here in Ireland at ASB Networks to meet some of these innovation challenges. Norella Constantinescu will give an Ensoy perspective, just published the implementation plan for the research and innovation agenda, and that it indicates a lot of opportunities for collaboration. And then finally, Dolph Gielan from IRENA will look at their energy transitions outlook and how that can point to some collaboration opportunities. So I'm really excited about this discussion. The format for this morning is that we'll each take a little bit of time to give a perspective. We'll have some time to discuss that perspective. Feel free to use the chat. We'll open it up for discussion after each session to have some discussion around that particular perspective. And then at the end, we can look at a more general discussion around collaboration opportunities. So that's the agenda this morning. And I'll look forward to it. So I'm going to start out with giving a perspective on EPRI priorities, and then we can go for there. I pulled a few of the real of the important elements of the Fit for 55 agenda that relates to the fact that we want to try to get here in Europe a 55% reduction in greenhouse gas emissions by 2030. This is a series of measures that will accelerate our decarbonization process here in Europe. And these are a few of the points that Dolph or Roberto, correct me if I've got these wrong at all, but a minimum of 40% renewable energy sources, that's up from 32%, in the final energy consumption by 2030 across Europe. And across, of course, each state has their own targets that need to be addressed as we get there. An overall EU level target for energy efficiency improvements of 36%. That's up from 32.5% for final energy consumption, and 39% efficiency for primary energy consumption. These are very aggressive targets that influence our research requirements around buildings and industry energy efficiency measures, and as well as other energy uses. We need to accelerate the deployment of infrastructure for reducing the carbon footprint of our transportation sector. And we're talking about recharging or refueling vehicles with alternative fuels and getting a infrastructure in place for that. So, you know, in the EU, we're looking at a new target of 100% non-emitting cars and vans for 2035. So beyond that, that's the only kind of vehicles that will be sold, and that means we need to have the infrastructure to support those numbers and integrate those charging vehicles with our overall energy system. And then finally, I think it's important, and it influences our research agenda as well here at EPRI. It's very important for us to the U.S. and other ones, the social climate aspect of these targets, energy efficiency targets, resiliency requirements. How are we going to make sure that folks don't get left behind in that process, that maybe have more difficult time affording some of the changes that'll be required. So that's a very important aspect of the agenda. So these are some of the areas that I think open up a real opportunity for collaboration. Threw a slide in on the recent publication from IEA around a 10-point plan to reduce the European Union dependence on Russian natural gas. Some of these are measures that can be implemented right away in the categories of tax structures and incentives, but they also are measures that require very quick innovation measures around accelerating the renewables integration with the grid. And, you know, that's something that obviously has been at the top of our list for some time, but we are getting to the levels of renewable integration where the challenges get more difficult to make everything work. So there's still a lot of innovation required there. You know, we talked about decarbonizing buildings and industry, and heat pumps are a big part of that. And these are measures that can be accelerated as well. Accelerating energy efficiency, that's, you know, was right there in the 55 package as well. And then flexibility, and making sure that our flexibility resources, you know, instead of all being based on natural gas, that are really taking advantage of energy storage, and in the future hydrogen, to make sure that we can make the grid work with the high level of renewable integration. And I think the whole Ukraine situation just reinforces the direction that we were headed anyway, and requires us to accelerate that process, in some cases very dramatically. I also, in the 10-point plan, talks about taking advantage of, you know, nuclear resources that we have now, and biogas, and those are things that, in terms of the integration with the grid and security, may influence our research agenda as well. So very important time in our industry to make sure that we have the energy resources that we need, and it's reliable and resilient. We have had shown this graph at EPRI. This relates in particular to the U.S. situation in terms of a pathway to net zero by 2050. And you can see it really follows the challenges in Europe very closely, in that we have to continue to decarbonize the electric sector, and we've done a good job of that Here in 2020, you can see that we've significantly reduced the carbon footprint in the electric sector through renewables, but especially replacing coal with natural gas. And so going forward, the challenges are become more and more substantial as we have to depend more and more on renewables and beyond 2030 and technologies like hydrogen to get there. And at the same time, we have to really convert the transportation and the heating requirements of industry and buildings to non-carbon producing energy sources and very likely electric. And getting there requires a lot of innovation as we go forward. So it does introduce a lot of opportunities for collaboration. Some of the things that I think are at the top of the list, and making the system more decentralized, integrating distributed resources, and really making distributed resources we call DER dependent, but an integral part of achieving the resilience and reliability requirements of the grid. And that means using these resources for flexibility as well as primary energy sources. And so that's a very important challenge area. Reliability and resilience becomes more important than ever. And we'll be talking a lot about this year with EDSO and Ensoy and Eurelectric. We have a number of sessions talking about the research challenges here, and they cut across a wide variety of topics, from the resource adequacy for the energy sources themselves to the ability of the T&D system to meet the requirements for delivering that energy, to the balancing and flexibility requirements, which can have an impact on the reliability and resiliency as well if we don't have enough flexibility. And then figuring out what the grid looks like with grid forming inverters and very high penetration of renewables from a stability point of view. All of these are critical areas for the overall grid resiliency that only become more important as we continue to electrify more and more of the loads. Looking down the line a little bit, and maybe with a need to really accelerate this process, hydrogen becomes very critical. So cooperation around the hydrogen research agenda, from production to the delivery infrastructure to how we get it, how we use it in a variety of applications, are all very important research topics. So a lot of innovation requirements, and we kind of like to lump them into two categories: the kind of technology innovation itself, getting the low carbon technologies that we're going to require, the technologies to automate and manage the grid with these resources as part of it, integrating electric vehicles, charging, integrating the flexibility to make the grid work, the transmission and distribution infrastructures that will be part of making this work, are significant technology innovation challenges, but also innovation in the area of policy and regulation. And for a research organization like EPRI, we don't do policy or recommend policy, but we do inform the policy and regulation community in terms of the impacts of different policies and regulations that could influence our ability to manage and operate the grid economically and in a socially appropriate way. So informing innovation and policy folks on different scenarios and their impacts is an important part of our research agenda, from market design aspects to structures for integrating the distributed resources and integrating communities, and metrics to measure our progress in these spaces that will include social equity kind of metrics as well, that can be used to as part of our planning process to design this next generation grid and energy resources based on these challenges. So very important categories of innovation that are there. we've been using this slide. I won't go into the details here, but basically decarbonizing the electric system, making sure that as we do that and we electrify critical energy systems like transportation and heat, that we really assure that we're going to have a resilient system for delivering that electricity, and as part of that, as doing that as in an affordable manner as possible, the digitalization will be key. Getting the sensors and the information structures, the data for analytics and optimization, and managing this more complex system, that digitalization is going to be the key for this transformation. So, and that's something that clearly we need to work on together, from artificial intelligence and data analytics to cybersecurity, absolutely critical. And so we'll be talking about a lot of these things during the workshops this week. We're kicking things off here this morning. We got 2 sessions this afternoon, one around resilience and the other around buildings and energy communities. Tomorrow we have 3 sessions that I think will be very interesting. So just keep track of the schedule, join in your areas of interest, and spread the word to your teams that we really look forward to participation in these sessions. As Robin mentioned, we are recording the sessions. We'll have them posted for sharing and reference afterwards as well. And with that, I'll open it up for any quick comments or thoughts at a high level before we go into a few perspectives from our experts that we have here today. Let's see here. Stop sharing. Figure out how to do that. All right. While I was presenting, I really couldn't see the chat, but I will open it up and see if there's any people are saying hello. That's great. But see any critical questions in the chat right now. Maybe we just get on with the perspectives here, and I'll have some questions, and folks online might have some questions as well. So what I'd like to do is turn it over to Roberto to give us a perspective from Ensoy, and as part of a group of organizations published some thoughts on policy implications of the Fit for 55 package, and maybe those thoughts will be interesting to talk about from a collaboration point of view. Roberto.
Thank you very much, Mark, and good morning, everybody. In this first day of spring in Brussels, is crisp. We have no seagulls out of the window, on the contrary, as Mark, and we have out of the window something that should be added to the discussion today. And it is not just the war situation in Ukraine, but the repercussion that this has generated in the past month on the energy prices, and the disturbances and disruptions in the dynamics of the gas and electricity prices all throughout Europe. This has also ignited, obviously, a series of considerations and questions about the validity and the possibility to pursue the objectives and the targets of all the packages that are on the table with the Commission, the European Parliament, and the European Council. I had several talks with officers and high-level officials at the Commission, like many of my colleagues, also around this table. And the perception is that the targets will stay the same. So there will not be a misuse, so to say, of the current situation to revise the targets. Obviously, you have noticed over the past months some profound revisions of parts of the commitments that had been expressed in the Green Deal packages, and probably taking into account a new reality should or could be influencing what is going to be the discussion of the future. So I was questioning myself if the positions and the comments that I am going to use today, not only on behalf of Ensoy, but also on behalf of Eurelectric and the Geode, since we arrived at a joint position on the Fit for 55 package quite recently, should be or are still of momentum and are still valid. I went through that for part of the weekend, and I would say yes. And there is probably no reason to stop everything and to profoundly revise the Fit for 55 package. There might be some delay. Realism should or could enter into the process. Probably the next Parliament and the next Commission will be different from this one and might revise something, but structurally, what we are discussing here today and what will be discussed by EPRI over the next sessions of their seminars week still has a validity. So just to align on and bring also the participants, all of them, I say affiliations and names, and many are very much known, so are expert in the area. But just to be on the same page, we are talking here about three directives, and sorry, 2 directives and a regulation, to be precise, and they are all interacting one with another. So the Energy Efficiency Directive, it is absolutely on the energy efficiency, and is targeted for the deployment of solutions at both grid, which is what is very interesting for us, and customer level, which is central for the distributors as well. The Renewable Energy Directive improves the framework for integration of renewable and spans on all the technologies that have to come, and that the exhibit that Mark offered on the developing technologies and approaches is very much indicative. And the regulation, finally, for the deployment of alternative fuels infrastructure is absolutely key for what is coming next, not only as far as flexibility services are concerned, e-mobility or other efficiency solutions. And following this regulation, probably many decisions of the Commission that have been addressed in the past will be revised. There will be probably a reopening on the aspects of the forms and validity of the storage technologies and the access to storage, both for prosumers and distributors and market operators in the future. But maybe this is a little bit too anticipated. So we have been discussing these among the DSO associations in terms of policy, and we suggested some considerations to the Parliament and to the European Council. First of all, the investment in infrastructure should be guided. Additionally, by a life cycle approach, safeguarding the sustainability objectives. Obviously, climate protection, security of supply, and competitive pricing. What does it mean? It means that we envisage the availability and the necessity of a guiding structure in the future discussion as far as the principles of the energy efficiency interventions are concerned, because this stems from an evaluation of the need of a better and efficient and more efficient methodology for the cost-benefit analysis at our DSO operative level. We released 1 year ago a study that has been quite successful, and that was depicting the necessity of investments on the grids in the area ranging from 375 up to 425 billion euro until 2030 for the distribution system operators in the European Union. The study had been conducted by Eurelectric, EDSO, and Deloitte with the support of leading DSOs and electric associations around the Union. It is still available on the websites of Eurelectric and EDSO. It is called Connecting the Dots, if somebody is interested. The data in there are still extremely valid and are more and more valid after the situation that developed in Ukraine, and let's hope will not extend to other areas of Europe. Going back to the comments on the energy efficiency directive, we also stimulated a reflection in the policymakers that the member states must be guaranteed a flexible approach to its implementation, both in terms of measures and in terms of obligated parties. In some countries, identifying DSOs as the obligated parties to provide energy savings specifically to low-income households to address a situation of poverty has not always been successful, but a source of distortion in the retail market. So this is a quite a delicate aspect, and these will require further reflection, not only at the country level, but also based on a comprehensive approach and analysis at European level, especially when prices have become a critical part of the market dynamics, and this might increase the percentage still well over the 22-23% of energy poverty level in the European Union. This data is unofficial but widespread in all countries. We think also with Eurelectric and Giode that it is important to avoid that the DSO become the main obligated parties due to the monopoly in a geographical area. The obligation from the DSO perspective should mainly be to inform consumers about the energy saving needs and to encourage it. So quite delicate, quite particular, but essential in the debate for the energy efficiency, even more important in the current framework. Then we analyzed energy efficiency from the point of view of the smart meters, and there are no further discussion there, because the smart meters for electricity are the cornerstone for everything else that can be or should be implemented in line with the Energy Efficiency Directive and I would say the rest of the package. And going to the conclusion of our observation here, energy infrastructure and network losses should also be better addressed in the formulation of the directive, will be better formulated in the formulation of the directive, and we believe that there should be needed an extra technological and practical approach in order to keep the pressure on the control of the whole of the assets and the functioning of the controls of the transmission assets. A larger responsibility as far as energy efficiency is concerned stays in a better focusing of these provision aimed at reinforcing the infrastructure investments which contribute to the energy efficiency. We are pressing a lot on the need of a much more clear and supportive approach from regulators towards the investments that are needed and that are already planned by the DSOs. And just reminding that in the current years and until the end of this decade, and probably a little bit beyond, the efforts of the DSOs will be ranging from 50 to 70% more than the average of their investment in the past 5 years. And that is to cut it short, what is our view, most of our view on the energy efficiencies. Let me conclude on the energy services, where a clarity and more coherence with the electricity market recognition should be the focus, keeping the DSOs in a role of neutral facilitators of the market tools that are going to develop. Once again, we would wish ourselves that the regulation will be as dynamic as to allow for evolutions of technology and market techniques that can be functional to the right evolution of investments and convenience for the customers. Renewable Energy Directive, it is something that has been in our focus, obviously, and it has got a lot of little technical provisions that we have been exploring and then insisting with the policy makers. But in terms of global approach, we see that one of the keys that is related to the smart charging infrastructure must be considered as crucial in terms of information for national and local planning processes. So this must go along with the planning of the development of the grids. And the charging infrastructure must be technically ready for smart charging and the cooperation with the grid. And this is particularly central in the evolution of many DSOs. And I have recently visited in Vienna the Aspern Plus experiment, and maybe somebody is familiar with that. And there the aspects of smart charging are put on an emphasis that is really stress testing many functionalities and is ready to cooperate with the grid. The obligation on smart charging and bi-directional charging functionalities goes hand in hand with the installation of smart meters, once again, at prosumer level, but also at distribution level in terms of transformation facilities and substations or last mile substation. That is the only possibility to be really flexible. This goes obviously along with an approach of non-discriminations in terms of applied technology in the smart metering. On the whole of the recommendations can be considered functional also on the regulation on the alternative fuel infrastructure, where still the role of smart charging and smart meter is reported as essential. And here the conclusions is that many of the recommendations that comes from the DSOs are really meant to ask and demand and support the request of a forward-looking and, to use another Brussels jargon expression, fit-for-purpose regulation. The EU climate neutrality, and I am quoting here, would benefit from a DSO sector equipped with the right tools to facilitate the integration of renewable sources and flexibility services, the uptake of electric vehicles and deployment of energy efficiency solutions, while ensuring constant supplies of electricity of appropriate quality to customers is essential for the pursuit of the objectives of the Fit for 55 package. So this is the political and policy approach that we are developing together. Do not forget that behind all of this, there is a huge development of technologies to come. And I would like to conclude on the technologies aspect, putting only EDSO achievement on these. We have got a strong technology committee working within our association, and technology is, along with policy, the second very strong pillar of our activity for the service of our members. And as far as technology is concerned, we are working as DSO now on 46 technologies that will prove either disruptive or essential for the development of the grids until 2035. And 2035 is not just postponing for another 5 years the limit, but it is the reasonable evolution that we foresee in these 46 technologies that are already under study, under development, at hand, many of them under implementation, but the rest will come and will help to transform the world of distribution, and let's hope for the better also for another grid that will be totally to be reconstituted, and it is the one of our Ukrainian neighbors. Thank you very much.
That's great, Roberto. And of course, we look forward to working closely with EDSO on these technology challenges going forward. Ellen had a question and I had a similar question. So we'll just hit that one before we turn it over to Ellen. It sets up Ellen's presentation nicely. And it relates to you mentioned the need for cost benefit methodology improvements, but so much of what we need to do at the DSO level is absolutely critical, as we need to make sure that we have a resilient system as we integrate more renewables and electrified transportation and electrified heat, and doing this in a, maybe with metrics that are needed to include social aspects of that resiliency and efficiency. How much of those investments are really just, we have to do it, and it's not a matter of cost benefit, it's just a matter of those investments are actually small in the big picture compared to these societal impacts if we don't have the resiliency and reliability there. Is that a changing picture as we look at the immediacy of some of these changes that are required?
Thank you very much, Mark, for having elaborated on the question that Ellen has put in the chat, and thank you very much, Ellen, for your question. The answer is the one that Mark, you know this since we are talking resilience since a lot of time now. The answer is really that resilience should stop to be considered a reactive sector of the grid management, and should be instead a built-in feature of all the investments that you are planning, or that we are planning on our grids as DSOs. What does it mean? Resilience by default. Resilience by default means a capability of foreseeing what is not the most common, but the most impacting array of damages that you could figure out, and try to structure your grid in order to minimize or to manage in the most rapid and efficient way the possible damages that you incur into. We have seen in the immense disruptions that our friend of DTEC have been faces in many regions of their country in the past weeks, that the cable disruption has been massive. We have seen that the most important interventions, first aid in terms of grids, have been generators that EDSO members have provided, among others, but we provided from our members the immediate dispatch of 7 generators within the first week of conflict within Ukraine, and that the internet connection to manage the grid is essential. And DTEC communicated today that they received as aid, as support, satellite internet servers from Elon Musk in order to bring their grid back into minimum management capability. So probably in these moments we see that that there are things that are not just physical connections that become important, but certainly beyond the transformers and cables, there is also all the software capability that comes into account. So yes, of course, resilience is the resilience that we all have in mind, but we should put a lot of efforts and a lot of investments to go beyond the floods, wildfires, and extreme weather episodes or facts for that. I see also another question.
I think they're all related.
But maybe it takes too long to answer.
I think it's probably, Ellen's going to elaborate on some of these exact issues in terms of how it's
exactly. Looking
impacting
forward.
actual DSO planning and priorities for investment. So it might be good to just move on to that and come back to these issues as after we hear from Ellen in terms of that perspective. Does that work for you, Roberto?
It works. Looking really forward because the remarks are very interesting, especially the first one. Thank you very much, Mark.
All right, Roberto, thanks for that perspective. That's great. Ellen, I'm going to turn it over to you. Ellen Diskin from ESB Networks, heading up their National Network Local Connections program, and it's a very exciting program that we're following closely here in Ireland.
A million for that, Mark. So just to check, can you see my screen and can you hear me?
Yeah, it looks good.
Okay, first hurdle cleared. So hi there, folks. Listen, thank you very much for being with us this morning. My name is Ellen Diskin, and like Mark said there, I lead ESB Networks' National Network Local Connections Programme. Firstly, ESB Networks is the Irish distribution system operator and transmission asset owner. So in Ireland here, we manage enough network to wrap around the globe 4 times, and with that, we serve all 2.4 million Irish homes, farms, businesses, and communities. In my company, our purpose is to provide universal, affordable access to electricity, supporting social and economic growth in communities and businesses across the country, and that's common with DSOs across Europe. Now what we want to do is repurpose our network to help drive the carbon out of society. Now, Mark and Roberto have brought you through some of the really big things that are happening in the policy world and in society around us. What I'm going to bring you through is a view from the front line as a DSO committed to rolling out flexible new solutions to support renewable generation and the electrification of heat and transport. So I think touching on those, this is necessary. Yes, I'm sure there is a long-term economic benefit, but really this is about necessity. So I hope what I bring you through maybe triggers a few questions or comments or ideas. Honestly, I'd love to get into a discussion on some of this. Now, the first insight from the front line that I've got anyway is there's always a risk that you're missing the big picture. Do you ever feel like you're missing the big picture? Okay, I'm going to give you an example. In Ireland here, we are #1 in the world for onshore wind, and we are really proud of it, with as much distributed wind generation as we have peak demand. So on average, 40% of the electricity that we consume in Ireland is renewable. We operate at penetrations of up to 75% non-synchronous generation. So, big deal. But still, maybe there is a bigger picture. The bigger picture is we are a society of people, of homes and farms and businesses and communities. And in that bigger picture, just 25% of the energy consumed by an average Irish home today is electricity. And that 25%, that's what today's electricity infrastructure is designed and sized to support. But there is this better future that we are fighting to leave behind, with homes running fully on electricity, 1 car and 2 electric, 1 home and 4 electrically, solar panels on more roofs than not, warmer homes and cleaner air. And if you want to talk big picture, our renewable energy successes to date have been down to supply side changes. So a small number of big companies changing the fuel that went into the electricity system by connecting wind farms. So without ever having to make a conscious decision, our customers' carbon footprints dropped. But to get to an average of 80% renewable electricity, so that's the Irish target for 2030, we'll need to see demand side changes. So millions of individual households making conscious, independent decisions to choose electricity, electric heating, electric transport, choosing to take that 75% fossil fuels out of their homes and businesses. And then millions of individual households changing their behaviours. So driving their own carbon footprints down by choosing to use or store energy flexibly when it's available and when it's local. Just think about it, do the math. Firstly, our infrastructure is sized for the society that ran on 25% electricity. Why we will need to upgrade that infrastructure, just like in transport or in telecommunications, the answer to more traffic and more usage, it's not just widen the road or add more copper cables. Part of the answer is getting smarter about managing the traffic. And secondly, sunshine with a load factor of 10 to 12% and wind with a load factor of 30%. In isolation, how do they deliver 80% average renewable electricity? We can't control the wind or the sun, so hitting those numbers will rely on our customers taking control of when they use electricity. Now, in Ireland, like many places I expect, our climate action targets used to be all about penetrations of EVs and electric heating and renewable generation. But then last year, the Irish government stood up and said, hold up a second, the numbers don't add up yet. And they introduced a national target in Ireland for 20 to 30% of system demand to be flexible by 2030. The target is based on engineering and science, and it does make the numbers add up. So the program that I lead, National Network Local Connections, it's about doing everything that we can as DSO for our customers to be able to be part of that 20 to 30%. So we've got a plan in 3.5 phases. Phase 1 last year was high-level design, delivery planning, and consultation. So we took a year to step back, analyze the system, consult with experts, research our customers, engage with our stakeholders, and get a picture of where we are going here and a plan to get there. And you know what? After 12 months and almost 50 engineers, economists, communication specialists, researchers, and analysts, we don't have all the answers. But we are starting to ask the right questions, and to get more answers, we know that we now need to get out into the field and start trying. So now we're rolling into phase 2A, which is 3 years of agile piloting across the country to build out capability in parallel with building out the longer term control room technologies like forecasting, optimization, and DER communications. And then in phase 2B, with that underlying operational technology going live, we'll be able to start replicating successful pilots out to 50% of our service area by mid-decade. And then phase 3, that is about building and building towards those 2030 targets. So last year, in that high-level design phase, in collaboration with stakeholders from right across the Irish energy and sustainability sectors, we delivered 10 technical proposals setting out the direction of the programme. Now, you might ask why 10? Well, Mark touched on it a bit earlier in the context of innovation. There could have been 100, with issues from power system engineering to customer attitudes and behaviours to OT and cybersecurity to market design and incentives. We started that 12-month intensive analysis and consultation and design in our safe space as a DSO. So we got out the research papers, the network models, and we sat down with peer utilities from around the globe and with the team in EPRI there on interconnection standards. We worked with technology companies as well as experts at home in Ireland. But the thing is, your safe space isn't where you solve the bigger picture. So we had the courage to say, this isn't just about us. This is about our customers. It is about organizations up and down the supply chain who will make this work for our customers. So we commissioned a huge body of customer research with over a dozen focus groups nationwide, with people from their 20s to their 70s and stakeholders from technology startups to farmers. And we asked, what does flexibility mean to you? What would motivate you to become flexible? What are the barriers? What's in your way? And who do you want to see breaking down those barriers? Then we collaborated with stakeholders in the renewables and demand response industries on newspaper editorials and radio podcasts. Because the thing is, normal people outside of the bubble that all of us on this webinar live in, they haven't a notion what we mean when we say flexibility. But if we are truly committed to 20 to 30% of those normal people's electricity demand becoming flexible in a few short years, then we need to start building familiarity and then curiosity, and eventually we'll get to awareness and empowerment. Now, once we had managed to really dig under the surface and put together some serious proposals, we published them, we ran public consultations and stakeholder webinars, and we asked stakeholders directly for their view, and they stood up, or they spoke up, and we were blown away by the insights that they shared. So we adapted our plans, we made some really substantive changes, then we submitted them to our energy regulator, and now we're resourcing up to deliver 7 pilots nationwide over the coming 3 years and a national rollout from 2025 onwards. So for us now, 2022, it's about building momentum by mobilizing and recruiting for pilots, consciously adapting then. So we went into 2021 looking to define a vision and a direction. We're entering 2022 mature in the knowledge that to succeed, we're going to need to adapt that vision. We want to get stakeholders' fingerprints all over the program, from the steering group to scoping the customer research to setting the pace and piloting. We're just coming out of a review of the flexibility market management systems landscape, comparing own software and software as a service and market as a service offerings, and we're now really hungry to find a partner to work with. And finally, 2022 will also be about looking inward and working within our own organization on training needs analysis and organizational readiness, because honestly, I cannot understate how much change this will mean for my own organization. Now, there's nothing like a steady stream of work to apply that focus to. So in 2021, we began to recruit industrial and commercial customers for local market-based flexibility pilots going live from Q4 this year in up to 20 sites across 5 locations, which we whittled down from a short list of 20 locations where there were known customer needs. And then successive pilots agilely build on each other. So pilot 2 introduces forecasting and power flow optimization to solve localized congestion so that the customers in green here, in roughly 50 locations, can provide market-based flexibility services to our transmission system operator. The reds then, those are 2022 recruitment, so we've got to go out and find participants this year for 2023 go live. So pilot 3 there, what we want to do is introduce contingency analysis and something we're calling effectiveness factors. So we could launch new flexibility products that allow customers to stack their flexibility revenues. And initially we'll pilot that at 1 location of scale with up to 1,000 domestic and commercial customers participating. Then in pilots 4A and B, we want to begin balancing renewables output with demand and contingencies in up to 20 locations nationwide, offering flexible connections for wind, solar, and community renewables projects. And then finally, we have pilot 6. See, people really struggle to wrap their hands and their heads around flexibility. You can see it in the research. People want to make a difference, but they don't actually have the information. They don't know how. Electricity is doubly invisible to people. You can't see it about the house around you. And most people in Ireland anyway pay their electricity bills by direct debit. So it's out of sight and out of mind. How can you manage something that you can't see? So pilot 6 is about seeing it. Through agile development and test cycles, we want to roll out local energy dashboards using our local SCADA and sensor data. And then we gamify and measure individuals and communities' behaviors and responses. We want to start small, working with self-identifying energy communities in maybe 5 out of the 500 plus energy communities that are already there across Ireland. And then as we learn and adapt the dashboards, we hope to extend the offering to communities nationwide. Over the next 18 to 24 months, the dots on the map there, those are places where we are going to learn the reality of how both we and our customers respond to flexibility. They're going to be test beds for DSO personnel to learn new skills and ways of supporting our customers. And they're going to be locations where aggregators, suppliers, and technology companies can build sustainable new business models. So when in early 2025 then, we begin to go live on the technology platform to support flexibility at scale from the DSO control room, we're not just going to be getting to the start line, we're going to be on the road. So we've got a plan. 3 releases with a waterfall rollout of control room technologies, including ADMS, DERMS, forecasting and optimization. And then this agile program of 7 pilots to develop flexibility products and markets and services and participation. But is there still a bigger picture that we're missing? Probably. On the front line of flexibility, you learn to recognize blind spots. This isn't just a DSO challenge. This is a sociological, psychological, economic, communications, technology, market, and engineering challenge. But we can address our blind spots by collaborating with customers and stakeholders who bring other perspectives. So we're going to set up a consultative steering group who will play a role in shaping each pilot and each subsequent decision as this program adapts. Working with them then, we're going to continuously invest in evidence, qualitative and quantitative research, scoped hand in hand with stakeholders as we test our assumptions, learn we were wrong, adapt, test, and repeat over the life of this program. So thank you very much for your time. I'm really hoping that some of you are going to come out and start asking questions about this, because honestly, the value in sessions like this is in the discussion. So thanks for your time, and I suppose handing back to you, Mark, if you want to share.
That sounds great, and I'll second Ellen's comment that if you have any questions, number one, feel free to unmute yourself and ask it. And number two, put it in the chat. I had a couple of specific questions that, having been working with Ellen on some of these issues over the last couple of years, still come to mind for me. One relates to the role of energy storage, and going back to Roberto's talk, and I didn't ask Roberto this, but it's kind of a policy and position question. Do you think that some of these market trials will work in terms of incentivizing investment in energy storage to the extent that we're going to need for flexibility both at the local and the TSO level? Or do you think that there's going to be a need for ESB to be able to make those investments directly and put energy storage where you need it as a part of a grid investment, decision-making process? There are kind of the rules about, not investing in energy storage. Is that going to be a big issue for ESB, or do you think you'll be able to do this with markets?
So I suppose, first off, I really, really hope that us getting out and starting really trialing and piloting, and I suppose, just clarify, we're saying pilot, we're not saying trial in a, we'll try it out, but we'll give you no certainty. We're saying pilot in a, this is the first step in a long-term commitment. So let's get the language really clear there. We are piloting, this is a long-term commitment. We really, really hope that it does stimulate some solutions like that. In the short term, I suspect it may take a bit of time in that to get someone to make an investment in battery storage. You do need to give persistent confidence. You need to say this is the policy direction. This isn't just 1 or 2 years of something. So we hope so. Longer term, we've been thinking about some steps that we may need to take to stimulate that. So one is, whereas we are trying insofar as possible to be technology neutral in our flexibility tenders, we are saying that, well, no, there may be a case that we need to target certain technologies or certain types of customers through the program, just because we may not get the learning without a degree of targeting like that. And then also we started looking at, well, what else would we need to do if we were to try to do this? So whereas when you're running a tender for demand-side flexibility, you don't need to think about the physical infrastructure other than are they connected to the right physical infrastructure. Whereas if we were looking at incentivizing battery storage to come in, then something we need to look at is, could we offer an available bay in a substation for this? What ancillaries could we put in place? How could we make this an easier proposition for whoever's coming along? So I don't know is the simple answer. I do know there has been a lot of success in Ireland stimulating growth in battery storage. So there's a lot of battery storage coming onto the system. Unfortunately, for DSO purposes, it is sort of short duration, high power, low energy, so not really going to meet DSO needs. But it has shown us that if there's enough of a market incentive out there, then storage does develop. So hopefully it's the same for us, but we may need to take some additional steps to make it happen.
That's a good point. And I think before we go on to Norella, I think Adrian's question is very appropriate in terms of chicken and egg with the tools for planning the grid. versus actual rollout of the technologies like ADMS and DERMS integration. Am I phrasing that correctly, Adrian?
Yeah, no, I was just kind of thinking, you know, a lot of the utilities now are shifting a lot towards agile development of software tools because the future is so uncertain that you need to be able to be, you know, quicker and smarter with tool development. So I heard you saying there, Ellen, that it's going to be waterfall development of the big tools in the control center. So I was curious how that will kind of dovetail with the proposal for agile development for other tools.
Cool. Okay. So no, that's a really good question, and I'm glad you picked up on it. So thus, yeah, the big heavy duty mission critical OT tools where we're quite, you know, and every utility is the same in this, we are quite dependent on working with the vendors, and the vendors typically provide these through a waterfall methodology. It is tried and tested, it works. So those are going to be waterfall, but it's not just additional technological tools that are going to be agile development. Also, a lot of the capability development, so just definition of products and services, organizational design, a lot of those things. I mean, it's a perfect fit for agile development in that there's a lot of uncertainty. We could do the perfect design and we will start to test it and we'll discover, we didn't know something that we didn't know, and it changes it. How they're going to tie together. So with the ADMS and DERMS rollout, first of all, there are going to be, I'd say, 1 to 2 years where we're doing the underlying stuff. So data model build, putting in place basic components, getting engines stood up. So until you get into configuration, you know, power flow or power flow optimization, having that functionality is just having that functionality. You don't need to know the details of market design. You don't even necessarily need to know the organizational design to know you need that stood up. When we get into, say, year 3 of those tools being rolled out and we get into configuration, that's the point where we will want to know a lot, but hopefully we'll have gone through quite a number of agile development cycles on things like product design, organizational capability, so we're in a better position to inform those. But beyond that, I know it's become a real mantra for us, even in those heavier duty technologies, that we need a high degree of ability to configure those tools, because there will still be changes to come down the road, but we don't want to go anything that is bespoke for us. So we want to stick to configurability, so whatever a vendor provides, we're able to adapt, configure, but then we're not locked into a specific product and a specific setup that no other customer of that vendor is using, so it goes unsupported. So it may well be a learning experience, but we think just the time taken with the heavier duty OT, it could work. We'll get somewhere reasonably stable on our agile developments. But watch this space, and if you have ideas or if you know of other utilities doing similar hybrid waterfall programs, let us know. We'd love to share experience.
Yeah, absolutely. The 50 hertz, they're TSO, but they're doing some great work on that. I can send some stuff on to you afterwards if you're interested.
That would be brilliant. Yes, 50 hertz in.
They're German. They're Eastern Germany. Yeah, yeah. They did a public presentation. I'll flick it over to you in the next day or two.
Study sounds really good. Appreciate that.
Related to that, why don't we go with one last question here from John before we turn it over to Norella, in terms of just your impression of what the vendor landscape actually looks like to support your pilots and the direction in terms of DERMS and ADMS and the standards to support the kind of agile approach and interoperability that you're going to need. Is it ready, or is it you know, work in progress to a great extent?
I'd be lying through my teeth to say that it's sitting ready to go, but it is moving along. So no, the vendor landscape is definitely moving along. So we did a huge amount of due diligence, meeting with vendors, looking at roadmaps, doing demos, and what we've seen is that of the major vendors, a number of them have the functionality that we need, but very few of them actually have clients using them. So, you know, they can run a power flow, but it's the same as me running a power flow in Syncal or Synergy. You know, it's nicely set up, the data is perfect, it works. So it is work in progress. Now we're about to go to market for an integrated ADMS and DERMS solution. Part of the reason why we're looking for an integrated architecture is just given we know the applications are going to develop and there's going to be a lot of update upgrade coming, it would be better being on an integrated architecture where updating one application doesn't mean we need to then update every other application and every one of the bespoke interfaces. But no, in terms of the piloting, what we've decided to do is minimum viable level of technology for pilots until that longer term waterfall delivered ADMS and DERMS is stood up. That way, if things aren't as mature as they need to be, that's grand. It is a small investment that has been stranded. It's not something that is going to completely knock over the program. And also, I suppose, just thinking about resources. So maybe other utilities are better set up than us, but for us, really good OT resources are a scarce and valuable commodity. So we need to have them reasonably focused on getting the core technology in place. So that means by necessity less focus on technology being put in place for piloting. So no, vendors are developing, but put it this way, when we go to market for all of this technology, which is very, very soon, spent the weekend going through PQQs and RFTs and all of that, on the SCADA and OMS functionality, I'm quite comfortable that no, we can write out good, clear questions, get a yes, no answer and have confidence. Whereas when it comes to the advanced DMS applications and DERMS, demo, narrative, I don't care that you have an optimization capability. I want to see how you are applying it before I'm going to have enough confidence to actually buy into that tool.
Great stuff. Thanks, Ellen. Let's jump to the TSO level now as part of this discussion. Of course, the TSO and DSO coordination is a critical aspect still of our innovation and requirements for the next generation. But Norella Constantinescu has been responsible for coordinating the development of the research and innovation plan, as well as the recently released implementation plan. So looking forward to Norella's discussion to add to this overall picture. So Norella, I'm gonna turn it over to you.
Yeah, thank you.
Am I doing your slides? Is that the way we're doing this?
Yeah, if you can do it, it will be very helpful for me. Thank you very much, Mark, for this invitation. Looking forward to work also with the EPRI, of course, with ETSO and DSOs and IRENA as well, because we cooperated across these developments with many of you. We got input on this plan we put forward last year. We received comments, and in order to look in the future, we see that the developments around us are faster than we can even move forward with the papers we develop. But for this, we have to take into account a kind of robust framework, which actually allow us to put these new requirements in place rather fast. If we go to the next slide, I was trying to put there a little bit what we see from the 10-year network development plan of Ensoy, which is, of course, one of our products looking ahead. It was based on the clean energy package, of course, but meanwhile, Fit for 55 was coming last summer, and today we have the new condition, which is brought by the war in Ukraine. So you see here a little bit the projection from today in terms of renewables integration in the electricity sector. So it has to be doubled by 2030. I think Ellen was mentioned what is happening in Ireland. So you are ahead of these developments as a country, because you had these developments in wind, and of course you have maybe less interconnection than the other countries. We also see quite a big increase in the electricity need, demand. Of course, the energy efficiency is going to bring the energy consumption down, but it passed through the electrification. And I think what the European Commission and also IEA in the Repower communication and respectively the 10-point plan, they insisted also on electrification and of course increase of renewables integration. And investments, so yes, investments are important, and this is the estimation by 2040 for the TSO, so more than 100 billion euros, with an increased capacity of wind and solar 3 times than we have today. I think following the developments with the war in Ukraine, we wanted to see, and also Fit for 55, we wanted to see if in terms of research and innovation, we are still on the good path. And of course, what is important, it's not only to take these research and innovation activities, is to cooperate with the others and as well to implement those outputs of the projects. So I think the Ukraine probably context will bring the need for even faster electrification. So we were looking at the transport sector. Roberto was mentioning the alternative fuel infrastructure regulation. So yes, this is going to be the driver. We might see for the heavy-duty vehicles, there is still a question mark if they will go hydrogen or if they will go more electric. But probably we will have a push for the heating sector. So if I look into these new developments on the installation of the heat pumps, we have to integrate more wind and solar. And Mark, you mentioned all the issues coming with the stability management, which have to be put with the in a system dominated by power electronics, which have to be put in place faster. And what we also will see probably this increase of flexibility needs. And Ellen, I was looking to your presentation and seeing this quantification actually of how much of the demand you would like to be flexible. And of course, hydrogen. This is in the short term, probably it's mainly based on imports. We know that actually at European level, hydrogen was coming more mainstream starting 2030. And in Ensoy, we are carrying out now a study looking at the flexibility from hydrogen. And I will come later. We see that the major purpose for the hydrogen, of course, is to cover the, for the electrolyzers developers, is to cover the industrial needs first. So, and afterwards, it will be probably the services which they can provide to the power system. If we go next slide, Mark. Thank you. Here it is actually what we develop in terms of implementation plan report with 13 project concepts. So based on a roadmap we carried out, we developed in 2020, and due to actually the developments more recently, we have tried to prioritize certain actions in the next 5 years for research, development, and innovation topics. And you see there that actually most of these innovation related activities are related, of course, to the cross-sector integration. So I mentioned the electromobility, I mentioned the heating sector, I mentioned the hydrogen. Roberto was pushing forward the idea of smart charging for large-scale electromobility deployment. I think it's important from the point of view of the power system and the cooperation with the ecosystem, with the manufacturers of the cars, the charging infrastructure, and so on. The models and the tools to coordinate this multi-sector system operation and planning are important, and as well as the data models. each of us, we are coming from the different ecosystems. We developed our standards for the data exchange and so on. So there is, of course, the first integration vertically along the electricity value chain, but there is also the data exchange with the other sectors. And of course, the markets, because we combine the regulated business with the non-regulated business and the markets in order to provide the signals we were talking before. Then, in terms of electrification, we need indeed this flexibility potential into future energy system. Meanwhile, of course, we have to take care of the existing assets, so predictive maintenance and the CO2 footprint of all the assets have to be considered. So we have exchanges, at least at the level of the TSOs, on SF6 free assets deployment. And as well, for example, lead-free cables used especially for the offshore development. So most of the RES integration will come, of course, at distribution level, but there are deployments important also at transmission level, especially due to the offshore strategy. So for this reason, we need to develop this multi-vendor HVDC system, which should allow in the future the move from the radial connections, which now are the practice, more to a kind of hybrid and afterwards maybe meshed offshore grid. And therefore, there is a need to have this demonstrator, which should look into the market operational aspects, regulatory. So this relationship between cost and benefits, and how we do the allocation of the cost and benefits. The stability management, and of course, the integration of DC systems led by the deployment of especially offshore, and also the mass integration of renewables, are important. And the IT tools, use of artificial intelligence, and the control centers of the future. If we go, Mark, to the next slide. Here, this is the impact we looked upon from the point of view of Fit for 55. And what we see and insisted, so it's the faster electrification. So this is related to the sector integration, and the flagship number 2 we have in Ensoy, the electrification ecosystem, optimal cross-sector planning, heat storage, hydrogen, need for flexibility, and its value in all the time frames. So here we mentioned the market, so how we ensure that actually the signals are there for the different flexibility sources to be provided, but also try to framework a little bit the different methodologies which are used to assess the flexibility needs in different countries due to historical or energy mix reasons. So we see a multitude of those, and in order to come up with a proposal for example, for the adequacy or for the needs in terms of short term, depending on the evolution of renewables integration. So we need to have a kind of more harmonized methodology. Modeling and management of data sets. I mentioned the multi-terminal, multi-vendor offshore solution, stability management approach, and automated decision support. And all this, of course, is based on more data, digital technologies. I think you mentioned that, Mark. So we have a kind of evolution towards a data-driven service framework. And I would like to continue now. We go to the next slide. I think Adrian was asking this question. Of course, we need investments in the infrastructure, but we know that this were rather difficult in the last year. So the public opinion is not there all the time. It takes a longer time. And therefore, we have to put in place innovative solutions, which maybe are not so CapEx intensive. And the regulatory framework needs to evolve to become more agile in order to encourage actually the networks operators to invest in those type of solutions. We were trying to make a kind of assessment of where the TSOs actually are deploying these innovative solutions. Yeah, most of them sometimes enter into the category of OPEX, and due to the efficiency targets, so this might get pushed back. You see that in terms of deployment, so there is quite a lot which was done, especially in terms of controllability. Then there is also smart asset management. The TSOs deploy or they intend to deploy solutions. A little bit less, it's done in the smart grid planning. So here, of course, there is the evolution of the digital twin. There is this coordination TSO DSO, and then as well in terms of innovative system operation. The use of artificial intelligence, capacity expansion, and improved security assessment by dynamic line rating. So here there are quite big uptakes. So it's important to develop the innovations, but it's also important to apply them and to work together with the whole ecosystem for these deployments. And I will close by mentioning on the next slide a few activities. Of course, I was looking especially at the,
Before I go to the next slide, the horizontal scale on this slide, is that if we look to the last bar on the right, is that all the TSOs in Ensoy? Or
no, it's a sample of 20 TSOs.
A sample of 20. So that if we went all the way to the right, it would be all 20?
Yeah. If we go there, it's we wanted to aggregate because this is not something, so I gave it as an example. It's not something which is completely public from our side. So the answers are aggregated, but you see a little bit more or less. This gives an indication what is applied and what is less applied, or which are the intentions for the application of different smart solutions.
Yeah, it's very interesting. Okay, I'll let you go forward now. Sorry about that.
No problem. And here I close. It's my last slide. So it's especially the cooperation with you. So with EPRI. Of course, there is this huge project TSO DSO and integration of distributed energy sources in OneNet. Which is, of course, a challenge, a huge project, challenging by itself because it's so big and tries to accommodate the different pilots which we have, in a huge number across Europe by actually developing these interfaces which allow to get into a kind of how to say interoperable architecture, the different platforms. Of course, the knowledge exchange which can take place in events. We work also together in ETIPSNet. So this is the European Technology and Innovation Platform for Smart Networks for Energy Transition. And what we try, and you saw previously on the slide which you commented, Mark. So this is based on this collection of technologies. So we have 65 type of fishes. mostly dedicated to assets, but many of them dedicated to flexibility solutions or to digital solutions, which we try to keep together and to extend. Now there is also the exchange with Ensoy to develop and to keep a kind of upgrading and updating all these technology sheets across Europe. And of course, at European level, we have Horizon Europe, where more calls are coming, so we try to influence. But what is important is to move together, on one hand, the research, development and innovation activities, and on the other hand, it's their application, and this passes also through the adaptation of the regulatory framework. So that's it from my side, Mark. Thank you.
That's great. Ellen had a couple of good points. Why don't I just give you a chance to jump in, Ellen?
Thank you for that, Mark. Norella, that was a really, really interesting presentation. Thank you so much. I love the data that you brought to us. A few things that struck me, trying to find my own questions now. Okay, the Rdi Acceleration Mission, if you could actually bring us back to that, because that was a wonderful graphic, just really brought things to life. And okay, so topics for acceleration. This, just the focus in it on what we need to be able to support, I found is great. And data-driven services, faster electrification, optimal cross-sector planning, need for flexibility and its value in all timeframes, improved modelling, management of extended data sources, and then automated decision support. Honestly, you could lift and shift them directly into a DSO equivalent, in that over the last year, those have been the recurring themes. Even improved modelling and management of extended data sets, absolutely. I think we've spent much more time actually collaborating to broaden our data sets and then format them into something we could model than we spent actually modelling over the past year. So really couldn't agree more. And what I was thinking is, Mark, in the context of EPRI Europe, there might be scope there maybe to do something in collaboration with the DSO organisations on a distribution equivalent, and then bringing together transmission, distribution, seeing, okay, where are there commonalities and then where are there differences, just for efficient use of resources, and also just flagging, you know, to the organisations who haven't yet stepped back and said, okay, we need to do this, giving them, well, here's a roadmap of things or a menu of things which you may find if you got limited resources, focus them on these. So what do you think?
Yeah, I'll jump in. I think that's a great idea. And I think that, you know, an area like cross-sector planning and data sets is in particular kind of starts at the DSO level and boils up to the TSO level. So it's one where we gotta look at the big picture and see where the development requirements are and work together on those. And I'm sure Norella feels the same.
Completely agree. Thank you very much for this idea, and indeed we see actually this cooperation which is more and more closer, and for both, so for the cross-sector planning, because of course for electromobility, also for the heating sector, first there is this integration with the DSO. It comes first, and we saw the start actually with the electromobility. Unfortunately, Ensoy is not part of this consortium, but Ensoy is there together with DSO. So completely agree. Data sets indeed important.
Yeah, I think we can create an action. We can create an action item out of that suggestion, Ellen, for follow-up after this week, in terms of if there's some kind of joint activities that cut across TSOs and DSOs and EPRI, but potential facilitator. That'd be great. So watch for that.
Dead on, brilliant. Norella, the other question I had is, when you were showing us the survey of TSOs and who had adopted or were planning to adopt different practices, it looks like there was very little progress on grid planning supported by active system management. Now, I know that we have found similar, and certainly I could speak to the different even cultural aspects that are driving it on the DSO side, but just be interested in your view. In that TSO survey, what's causing the inertia?
I don't know if I understand correctly your so why it's so low?
Why so low? If you go to the slide, you'll see the very lowest uptake or lowest progress was grid planning supported by active system management. So it's as though we're piloting active system management, but we're not accounting for it in our planning practices.
So there we looked at the deployment actually. So to be honest, and I suppose that in that particular case, because I had this question also from the European Commission, if something should not be done in order to encourage actually this deployment by taking into account other solutions, so which are provided by the active network management. So we are in how to say, we have I suppose many pilots, but then to integrate all these pilots across TSO DSO interface and then to reflect this in planning, I think here there is still an additional step to be done, and we try to look into that point. I think Acer, so because Acer is looking at our products, for example, in the T1DP, is asking us to look how we can integrate, for instance, the distributed flexibility resources in order to assess the planning by looking at alternative solutions. And there is a kind of constellation of associations which are pushing also us in that direction, but we are not yet there. And indeed, this is a kind of activity where I think we should focus the attention.
Yep, I agree on that. For what it's worth, certainly in our organization, one way of coming at it that we found quite effective is talking about prioritization. In that, for us, I think part of the reason we're slow to do this is infrastructure takes so long to build that people are very cautious to say, no, don't start building. Whereas if we can have an honest conversation and say, you can use this to prioritize. So yeah, those critical infrastructure projects, they still go ahead, but by using active solutions, you free some of your resources up to focus on the infrastructure that needs to happen, while also meeting the need in those locations where you use an active solution. So, I suppose it's an area where we're all going to need to progress, but it'd be interesting to see what does happen if collectively we try to bring this together, because the pilots have to translate eventually.
Correct, yeah. And indeed, the focus is mainly on the infrastructure, the critical infrastructure, and I think it's going to be a kind of learning process to take into account other solutions as well.
Thanks, Narella. We have a good question from John in the chat, but I'm going to leave that. Maybe, Narella, you can look on the chat and check John's question about regional and country differences on technology adoption and how you take that into account as you have calls and track the technology progress. It's a good point in Europe and how we track that. But I'm going to move on to Dolph Geelan from IRENA to kind of give us an international perspective on these challenges and the opportunities for collaboration. I think it's a good way to bring us home here in this introduction to our workshop week. So Dolph, I'm going to turn it over to you and see if the sharing works for you, and we can kind of do the chat as we go.
Yeah, thank you very much, Mark. It's fascinating to listen to this discussion. Let me see. Okay, I'm going to talk about something completely different. It's role of innovation in the IRENA World Energy Transitions Outlook with a specific focus on green hydrogen. And let me say from the outset, we see direct electrification as a far more important part of the solution than hydrogen. And if you see the whole discussion at the moment, not everyone seems to be aware of that. So that is an important point to make. And of course, to make that electrification happen with, at the same time, much more variable renewables on the supply side, we need smart electrification and all these solutions we heard about. We talked about that in the context of our last innovation landscape report, where we developed a toolbox for flexibility. There is another innovation landscape report upcoming where we look specifically at electrification. And at a global scale, we see electrification going to maybe 50% of final demand. On top of that, another 8% or so comes from the production of green hydrogen and the use of green hydrogen. So it gives you a sense of how important these two solutions are in the total picture. Having said that, we do a lot on green hydrogen. We issued a report on the geopolitics of energy transition, the hydrogen factor, in January. We have a new report coming out on, in fact, a trilogy on hydrogen trade, and also a new report on green ammonia, and that builds on a couple of other reports we had issued recently. In a European context, what matters is for hydrogen is that the thinking has changed very significantly in recent weeks. Energy security has come to the forefront. Natural gas has been identified as a key concern. And in that context, the Commission has said, well, let's accelerate also green hydrogen. So, and the quantities we're talking about are significant. So if it's 20 million tons of green hydrogen, that means you need 200 gigawatts of electrolyzers. That means you need 400 gigawatts of renewable electricity generation capacity to feed these electrolyzers. So these are very significant amounts and very significant, let's say, investments. And that is also visible in the analysis we published last year in the 1.5 degree pathway, where even in 2030, we have around 50 million tons of green hydrogen requiring about 5,000 terawatt hours of electricity. So that's a very significant amount, and you see how that would need to grow going forward. So this green hydrogen has its significance for the electricity system going forward. I should also say, in this scenario, we have 2/3 green hydrogen, 1/3 blue hydrogen in 2050. If we would do it again, maybe we would even raise green hydrogen share further. The discussion is clearly moving in this direction. Now, for a European context, that means then where do you get the hydrogen? You can produce it within Europe, maybe also transport it within Europe, or you can ship it in from faraway places. There is a significant potential in Europe. We calculated about 88 exajoules, but there is vastly more potential elsewhere. And also a critical enabling factor for affordable green hydrogen going forward is electricity at maybe 2 cents per kilowatt hour. Not so easy in a European context, given also all the other demands for that electricity. So probably you're going to see some shipping. There's a lot of talks ongoing between your potential European importing countries and potential exporting countries. The German Minister of Economic Affairs was this weekend in the UAE to talk about that. And the question is a bit, what will that trade look like? We calculated that about a third of the hydrogen will be traded intercontinentally, or at least long distance, about half of that pipeline and half of that by shipping. And we see especially ammonia shipping as a key solution. Now, to make all of this happen, you need electrolyzers. Well, last year, about 0.5 gigawatt of electrolyzers was installed. For this transition pathway, for 1.5 degree, we need 350 gigawatts by 2030, 5,000 gigawatts by 2050. That means we need a massive ramp up of electrolyzer manufacturing capacity and also of installations. And of course, renewable power needs to grow in line with that growth. There were questions about flexibility of electrolyzers and how will they exactly integrate. I think that will also depend a little bit on how will the economics of these electrolyzers develop. So at the moment, still relatively expensive systems at about $1,000 per kilowatt. If we really go to systems of a few $100s per kilowatt, then of course you can operate them also with low capacity factors, but else you will need to combine different types of clean energy to provide the electricity needed to ensure that the capacity factors are sufficiently high. So we see a clear development, a positive development in production of green ammonia with green hydrogen. There's about 10 million tons, which we are fairly certain will come in place by 2030, which is about 5% of today's ammonia production worldwide. There's a pipeline of around 50 million tons, which is about a quarter. And much more will be needed also if you want to use ammonia, for example, in power plants, as the current idea is in Japan, say. So, and the advantage of using ammonia also is that ammonia shipping is relatively cheap. You can ship ammonia for $50 or $100 per ton around the world. And so it gives you a clean energy vector that you then can try to use for different applications. To make that hydrogen happen, you need an enabling framework. There are issues to deal with on the supply side, on the trade side, on the demand side. We developed together with the World Economic Forum a roadmap for enabling measures, have deployed that for Europe and for Japan, and tend to expand that now to other regions. And that is then the basis of discussion with the policymakers in the region, how to adjust these frameworks. A last word on what will the future electrolyzer look like. There is one important dimension to consider, and that is the materials needs. That varies quite a lot by electrolyzer technology. So especially the PEM, proton exchange membrane electrolyzer, uses a number of materials that are fairly expensive and fairly scarce. So either there must be significant materials efficiency improvements in that machine, or it's more likely that the alkaline electrolyzer will become the dominant one. And the PEM is slightly more flexible than the alkaline, but there are also improvements in the alkaline electrolyzers, and maybe that flexibility is enough. But I think there would be useful to have a little bit more discussions, and we're currently again looking at these issues. If you want more information, you can find all of this on our website. So thank you very much.
That's great, Dolph. And I think that progresses us very nicely from kind of our immediate concerns of electrification and supporting that to maybe longer term concerns, but becoming shorter in terms of integrating green hydrogen. And I had a question about kind of some of the numbers that you put out there, and is there a distinction between what we would need for flexibility and as a storage vehicle for longer term storage and flexibility requirements of the grid, kind of replacing natural gas for that purpose, and maybe, you know, a continually reducing amount of that's required for that as we have more and more battery storage on the system or other storage mechanisms, versus hydrogen as really part of the broad energy mix itself. Is there kind of the flexibility and storage requirement pulled out in the ARENA projections?
Yeah. So there's a number of reasons why hydrogen is deployed. So we also have hydrogen for power generation, so as a flexibility option in the power system. In fact, globally, 2050, a few hundred gigawatts of that option. But the main reason to deploy hydrogen is to tap into renewables abroad, or to deal with grid constraints. And the other one is that there is a number of key sectors, say steel making, jet fuel, etc., where you will need hydrogen to satisfy the energy demand in these sectors. So it's a mix of different reasons why hydrogen comes in, and flexibility is one of them. But it's then mainly, let's say, also long-term flexibility, I should say. Short-term flexibility, we see a key role for batteries. I haven't heard a lot about smart charging and vehicle to grids. We see that also as, for example, as a key part of battery storage going forward.
Yeah, no question. Ellen has a good question, and Narella has her hands up. So I'm gonna go to Narella as we wind down here. You gotta I'll unmute you there. I can probably unmute you. There you go.
Yeah, apologizes. Thank you, Don, for these insights. We have not yet published a study, but we looked also at hydrogen application for flexibility reasons towards the power system. And indeed, we had the three technologies you also listed at the end of your presentation. The assessment which we done showed that at least by 2030, there is not so much business case for the electrolyzers to provide to become a flexibility resource, especially for long term, because indeed this is the storage part. So we talk about the flexibility for weeks maybe and months, which is not provided by the other technologies. And the estimation was that flexibility might represent something like 5 to 10% of the revenues an electrolyzer will do, while their main purpose will be, for example, to provide industries, as you mentioned, so heavy industries with the supply for fuel which is not fossil fuel, so which is more carbon free. I don't know if this is the same outcome you got from your study. Okay. Thank you.
So fully agree with that.
That's great. And Alan's comment, and maybe just a good one to wind up on, is what do you see as the factors that are really going to drive an accelerated development of hydrogen solutions? Is the existing situation with Ukraine a big part of that, or are we seeing investments in R&D in this space really bear fruit and the cost coming down, or how do you see it playing out as you look in your crystal ball?
We think it's especially demand driven, and see that for example on aviation fuel, sustainable aviation fuel regulation plays an important role, so that a certain percentage of aviation fuels going forward needs to be sustainable aviation fuel. Then you still have the question, okay, do you go for advanced biofuels or for the synthetic fuels? But we see also an important role for the synthetic fuels. It's the same story in shipping, and we see currently a lot of activity around how to decarbonize steel. And after a long period where there was a lot of confusion, are we going for CCS, are we going for biomass, or are we going for hydrogen? If I had to bet now, I would put my money on hydrogen. That's where you see clearly most activity. So very much demand and regulation driven, creating a demand then for hydrogen, and then everything else will follow.
I think that's a very good place to kind of wind things up, and I'll just leave it with our workshop agenda for the week and the sessions that are coming up. I really appreciate all of the input from Roberto and Ellen and Norella and Dolph. I think it sets the stage very nicely for the high-level priorities and clearly the opportunity for collaboration as we accelerate a lot of these development requirements, take advantage of pilots like the ones that Ellen described, and really all learn together as we go through this process and meet the challenges of the energy transition, resiliency, and equity as we go forward. Equity is one of the things I wanted to talk about, and I'm sure it'll come up, for instance, in this afternoon sessions where we talk about resiliency and energy communities, and probably beyond that. But please join us for as much as you can of the sessions going forward. This week we also have the Bridge General Assembly going on. Many of you are probably participating in that. I know I'm part of that from the from the business model working group. But so there's always a lot going on, but join us where you can. And thanks to all the presenters for the great input this morning. Appreciate it. Have a great day. Thanks, guys.
Thank you, Matt.